Hello and welcome to ETG 4950. In this session we are going to identify the processes needed to produce one unit of a product. The flow of material and the assembly process will assist in identifying all activities required in the production phase. The session will also discuss selection of equipment, process analysis and design, production technology, and human resources required to complete these processes and activities. There are certain strategies that could be followed when producing a product. Those strategies might depend on the nature of the product or the company's strategic decision. The recognized or well-known process strategies are the process focused, the repetitive focus, the product focus, and the mass production focus. The goal of the process strategy is to create a process to produce a product that meets customer requirements within the cost and other managerial constraints. The project team should think on how to produce a product that meets or exceeds customer requirements with an acceptable cost and acceptable quality. To be able to provide or to deliver at the end the product, you need to think of how can I satisfy my customer. The selected process strategy will have long-term effect on the efficiency and production flexibility. So when you select a strategy, you should select a strategy that will meet or that will work with your product, because that process, once you select it, it will affect or it will have an effect on the efficiency and production of your product. The selected process strategy, as stated before, will affect cost and quality of that product. This figure represents product variety versus product volume. The graph also shows the different strategies in relation to both volume and variety. According to identification of your product and the demand, you can decide which strategy fits your product the most. And this is what you're going to do with the project assignment number 2. From the figure, we can recognize 4 strategies. From or process-focused strategy, which stresses on low volume, high variety, such as carpentry, where the strategy allows customization. We have repetitive focus, where the strategy stresses on repeating processes using modules such as automobiles and household appliances. This strategy has more structure and less flexibility than process-focused production. The product-focused strategy stresses on high volume, low variety, where facilities are organized around the products such as glass, paper, and light bulbs. These processes are also called continuous continuous processes because they have very long continued production runs. And the last one is the mass customization focus, which stresses on high volume, high variety of goods and services. This strategy is considered a rapid, low-cost production of goods and services that fulfill unique customer desires, such as Dell Corporation and its high volume with high variety of personal computers and laptops. Groups by now should be able to identify the proper strategy for their product. In process-focused strategy, facilities are organized around specific activities or processes, which means all operations are grouped according to the type of the process. In a factory, these processes might be departments devoted to like welding, grinding, and painting. You need general purpose equipment and skilled personnel to accomplish the different activities or execute processes. So you can notice that these departments will be looking for people who can accomplish these activities, who has the skills to do that. And this is what you are going to do. You are going to see or look at your product and identify the processes and then identify the skills required. If you don't have those skills within that team, then you can outsource it, or you can hire a contractor that can do the job for you, or hire a person who will be an employee to do the job for you. And that's just for, let's say, the purposes of your product. You will identify that and you will say that we need those skills or skilled employee to work on the product. It involves a lot of customization, which gives the product high degree of flexibility, but it has high cost and low equipment utilization. Product flows may vary considerably, making planning and scheduling a challenge in this strategy. For the repetitive focus strategy, facilities or workstations are organized as assembly lines. In most cases, it will utilize modules with parts and assemblies made previously. Those modules could be combined to provide different output options from the same product. For example, different models of cars. So you'll have all these modules that will be put together, like a transmission or the engine or the fuel pump. The fuel pump might be the same for 3-4 cars, but I can build different different models from that car with those components. This strategy has less flexibility than the process-focused facilities or workstations, but more efficient. In a product-focused strategy, facilities or workstations are organized by product. This strategy will be dealing with high volume but low variety of products, such as producing Lay's chips, different chips, few ingredients like the potato, the water, the seasoning, and then you will have few outputs which vary by the size, maybe by just flavor. The company will have long continuous production runs to enable efficient processes. This strategy is associated with high fixed cost but low variable cost. Less skilled labor will be needed for a product-focused approach. In the mass customization strategy, it stresses on fast production runs with low cost for both goods and services, which satisfies unique customer desire. One of the main features of mass customization strategy that it combines the flexibility of a process-focused strategy with the efficiency of a product-focused strategy. It's a very good example, or a very good example that can be explained for mass customization strategy is the Dell Computers company, Dell company. Their strategy was to create a process that will focus on customers directly through building what customers need and when they need it, with fast response and low cost. The process has been integrated through the company's website, from the browsing to selecting to customizing to ordering to paying, all online and within few minutes. Not only that, but Dell also focused on software design to be simpler and faster for configuration purposes. Mass customization is a collection of characteristics that is being learned from different strategies such as modular techniques from the repetitive focus, effective scheduling techniques from the process focused, and rapid throughput techniques from the product focused strategy. This will make the process design flexible and imaginative, but with tight schedules and limited inventory. This strategy will require responsive partners in the supply chain to be able to meet that tight schedule. With tight schedule, you need the items or the components to be there for you when you need it. So you need partners that can respond as fast as you need when demand comes. Selecting the proper equipment for a process could be complex. Selection criteria and evaluation process should be in place to evaluate alternative options and select the equipment based on certain factors such as cost, quality, flexibility, capacity, and other related factors. Flexibility is the ability to respond with little penalty in time, cost, or customer value. Although it might be difficult and expensive, but it might provide competitive advantage. Without flexibility, change could mean starting over, and that will be costly. To analyze the current processes and design better processes, we need to answer the following questions. Is the process designed to gain competitive advantage in the market? Now, you are designing that process to compete in the market. So you have to look at other processes, how it's been done, how do they build the product before you do your process to make sure that you are competing in the market. When design processes or when we are designing processes, we are eliminating steps that don't add value. So we need to look at all these steps that don't add value within the process or within the activities and remove them. Otherwise, it will increase the time and that will increase the cost. And then we need to ask, does the process maximize customer value? In addition, we need to ask, will the production process fulfill customer demand and compete with orders? All these questions, if we can answer them, then we will know that our process or our product can compete in the market. There are many tools, techniques, and methods that can be used to analyze an existing process or design a new process. One of them is the flowchart diagram, which tracks material movement through the production phase. Another tool is the time function mapping or value stream mapping, which includes all value-added activities in the system. In these charts and diagrams, special symbols are used to show key activities. This figure shows a time function mapping diagram that maps the process of ordering a product as a function of time. The customer will place the order and the salesperson will process that order, which will take 12 days to be processed. It will be 13 days in the production control to schedule the activities needed for production and to assign the required resources. Then it will be sent to plant A for printing, which will take 1 day. Look at the time waiting for the item to be processed versus the processing itself. Once it's done, it will be sent to the warehouse where it sits there for 4 days until it's been transported to plant B. It stays in plant B warehouse for 10 days, then it will be extruded in 1 day. Again, look at the time waiting versus the time that's being processed. The finished product will be sent to the warehouse to be shipped to the customer, which will take another whole day, and the total time from start to finish is 52 days, from the time of order until the time a customer receives the final product. And that's a lot of time for just doing this. So if we look at the time function mapping, we can find a lot of time that's wasted just waiting in the warehouse on the shelf for processing. It's waiting as it's not being processed yet. So if we can move the extrusion to be in the same plant and schedule everything to be done within the same day, then the whole process will take 6 days instead of 52 days. The time function mapping assisted in the analysis of the process, identified the problem, and provided the recommendation to improve the process. Another tool that we mentioned was the process chart. This figure shows a process chart for example here, hamburger assembly. Using chart symbols, we can identify the stage where the assembly is, including time passed in minutes and distance traveled. Using this chart, we can eliminate non-value added activities and increase the efficiency of the process. A fourth tool that can be used to analyze and design processes is the value stream mapping tool. This tool starts with the customer and extends all the way back to the supplier, mapping production processes and identifying value added and non-value added activities. To use value stream mapping analysis, we need to perform the following. First, we create symbols for customers, suppliers, and production to ensure the big picture of the supply chain. And then we enter customer order requirements and calculate the daily production requirements. Then we enter the outbound shipping requirements and delivery frequency. And at the end, we determine inbound shipping method and delivery frequency. Then we identify and add the processes the product will go through until it gets packed and shipped to customer. We will include the communication methods and their frequency, showing the direction of communications using arrows. We will add inventory quantities between every step of the entire flow. And in the last step, we determine total working time, value added time, and delay time, which is the non-value added time. And then we can eliminate the non-value added, or at least reduce it to ensure efficiency. In the next session, we will continue addressing tools and techniques used to analyze and design processes. That will be all for this session. If you have any questions, please feel free to use any of the provided channels. Thank you and have a great day.